Good morning. Good morning, Bangkok. Yep. Good morning, Anthony. Must be really early for you. Yeah, we cannot hear you, Anthony. Yes, you're on mute. No, we still, you cannot hear you. The organizer, do you want to check on the mic? But meanwhile, let me just give a brief introduction myself. Wai Lau, the CEO and founder of zkCandy. We are a layer 2 hyperchain focused on gaming as a result of a collaboration between MetaLab's zkSync's and iCandy, the largest game developer of Southeast Asia. Very excited to be here. Need to talk about a lot more about hyperscaling with Anthony. Anthony, are you able to try now? No, we still can't hear you. Let's just give a technical issue. Hang on there. Sure. Good. Yeah. Okay. Okay. Hey guys, we're gonna take another 1 or 2 minutes to fix the technical issue, but maybe let me just take a time to introduce zkCandy. We are a layer 2 gaming chain, as I earlier introduced, powered by zkSync's. The key for L2 gaming chain is, to me, it's really low gas fee and very, very fast. I've been developing Web3 games for last 8 years. Always been on the lookout for a chain that can fulfill our requirement, which is the gamers, when they click on a button, they expect something to happen instantly. It's not going to take 3 minutes before they get the next sword drop or, kill the next monster. So it has to be really, really fast. So with L2 hyperscaling solution in particular, zkSync's, it's really one of our key points. And of course, for a gaming chain, it's also, I think the objective now for us is to bring on the mass gamers. So frictionless, making it easy. There are certain features on zkSync's that really allow some of these onboarding process that we hope to see will drive the next wave of gamers coming onto Web3 gaming. And then, of course, on the other side of the equation, helping game developers to build games to easily adopt to the Web3 environment and framework will be some of the key features for zkCandy. We came from a long history of developing games. The team came partly from a game developer, the parent company. So we've been building games last 16 years, a lot of AAA games, working with many big brands in the world, Square Enix, Activision, Blizzard, Konami, just to name a few. Since 2017, we've been building games on Web3 as well. So that's kind of the background, and we really want to solve all the ecosystem problems that we face every day as game developers, gamers too. So that's going to be really interesting to watch. And I find GameFi, Web3 gaming as a segment would be probably going to see some big disruption going on. I think the next wave, seeing so much good gaming products coming on stream onto various chains, that's going to be a network effect. When there are more games, there are more gamers. When more gamers come, there are more people going to build games. So that's going to be a compounded network effect that I think will be really the part of the next wave of adoption for Web3.
Can you hear me now? You guys can hear me okay, right?
Anthony.
Hey, can you hear me now?
We can finally hear you. You're coming in a bit soft. Do you want to stay closer to the mic? Can you say something?
I think the audio might be on your side. I think the organizers are figuring it out, but can you hear me well enough, or is it too quiet?
Yeah, okay. I think we can hear you, but you probably need to speak a bit louder because it's still coming in a bit soft.
Okay, I will do my best.
Okay, cool.
Let me know if I'm not clear. I can repeat anything. Yeah, apologies for not being there in person. It would have been easier to do this together on stage.
No worries. Let's get started. Perhaps first a brief introduction about yourself for the audience.
Sure. So thank you for the invitation to speak. Excited to chat about all things zkSync. So I'm Anthony Rose. I lead the technical team at Matter Labs, which is the engineering team behind the zkSync protocol. I've been at Matter Labs for around 2.5 years. And before this was doing a bunch of other things outside of blockchain, but interesting technical problems with SpaceX, with Uber, and was doing machine learning for a long time, and physics a very, very long time ago now. But excited to be in crypto and in zk.
Very cool. There you hear it. We have a rocket scientist in the house. That's Anthony Rose. Next question for you. In terms of what Matter Labs' vision are for scaling Ethereum's technology and values with zkSync, can you tell us a bit more about that?
Yeah. So this is kind of like, I guess, the foundational question. Like, why do any of this? And I would argue that when we look at a system like Ethereum, it has really compelling properties that we, would like to make available to a degree that just aren't available with the system as it exists today. Properties like security, censorship resistance, trustlessness, resilience, and having a compute platform that's open, open source, permissionless, free to the world, but able to operate at global scale is really the vision for the system that we want to build. Like, how do you bring Ethereum to everybody rather than, where it is today? Because Ethereum pays for all of these really nice properties, as probably many people are aware, by not having the ability to scale, right? So processes of the order of, 12, 13 transactions per second, which is just obviously insufficient for anything that wants to sit behind, some future internet of value. So the vision for zkSync is to solve this problem. Like, how do we design a system that doesn't compromise these properties, but can scale horizontally in a way that the internet can scale horizontally? So you can use zk, and I'm sure we'll talk a little bit about more like what that means. But you can use these cryptographic techniques to build these compute environments that can, take these beautiful properties that Ethereum demonstrates, but build something that can, provide an application there for billions of users, not hundreds or thousands of users.
fundamental values like decentralization, self-sovereignty, while trying to scale Ethereum?
Yeah, this is a really good question. I would say the obvious part of the answer is that there are considerable technical challenges when you're building systems like this. What we're building is a brand new virtual machine, but you're building it in a way that you can use cryptography to prove that it's correct. And this comes with, you want to build something that's maximally performant because, to your point, right? The thing that really matters with these systems, if we get to realize the vision, is they have to be extremely fast, they have to be extremely cheap, they have to push to get, to be able to really provide a lot of compute for people to actually go build games or build DeFi applications or build social applications. It needs a lot of compute. So the system is complex and it takes, there's a lot of obvious engineering challenges in terms of, building the virtual machine, building the cryptographic component, building things like the compiler. So, these are like the obvious technical challenges. Some of the less obvious challenges include things like we're building in a highly adversarial environment. There's roughly $1 billion in the system. This is a nice incentive for bad actors. So we have to be extremely careful with how we build, take a really security-first mindset to the way that we think about upgrades or new features or any of these pieces. So you're trying to balance building this thing very quickly, building it where all of the code is open source, but also building it safely. And then when it comes to decentralization, this is a critical part of the system, but it's a part that honestly the roll-up space at the moment hasn't embraced as much as I think all of the roll-up teams would have wanted. All of these systems are still too centralized today, and you have to force yourself to make progress on this, because things like cost or things like performance actually have like very clear external pressures on, right? Like if your system is too expensive, people won't use it. If your system is too slow, like people won't use it. But the decentralization piece, because none of them are decentralized, there isn't such a strong external pressure. So the teams have to demonstrate discipline around this. So we have our decentralization arc. We've made a lot of progress. We'll be very soon, we have a version of the sequencer which is decentralized. We will be bringing that to mainnet. We have other things that are exciting that are coming in this direction. But the obvious reasons to do this are still there, right? Decentralized systems have much better liveness properties, right? If one node goes down, that's fine. The network just absorbs that, right? These systems are resilient. And for us, as we think about really getting towards the scale that I talked about a moment ago, like internet scale, it's just obvious that one company is not going to be in a position to run all the provers, to do to generate the zk proofs and things like that. So like opening the ability for anyone to contribute compute power to this is also a good scaling vector as well. So lots of challenges. But the key piece is that you design your system for these properties. You design it to be decentralized, and then you force yourself to kind of like walk the steps on your roadmap as you build it.
Very cool. Very cool. I think the challenges zkSync is trying to address, it's very clear. Now, the other thing that we often heard from the zkSync team would be concept like hyperchains, hyper-scalability. Can you perhaps share a bit about the significance of hyper-scalability and how zkSync aims to achieve it?
Yeah. So to try and express the idea simply, I would say we draw inspiration from the internet in a very clear way. So with the internet, whenever something new wants to be built, people don't really have to worry about, the limitations of the system, because you have this network and, you can scale horizontally effectively. You add more servers, provision new Kubernetes clusters, stand up new machines, and you're able to just build out this network by adding hardware. The internet doesn't have the limitations that I think we've been thinking about and trying to deal with in monolithic blockchain systems. So when we were thinking about, how do we really achieve scale for Ethereum? One L2 is not the answer, right? There's not going to be one L2 which reaches millions of TPS and, reaches the performance that would need for kind of the vision that we have. So you have to figure out, how do you bring these horizontal scalable property to this system? So hyper-scalability is this idea, and essentially there's a few pieces to it. One of which is you want to move away from, I would say, like how bridges have worked historically for blockchain systems. Bridges have been a weak point. Bridges essentially aren't bridges as well, right? So typically, for example, if you were going to bridge, say, between Solana and Ethereum, for example, you would park your assets in a smart contract on one side. You would have to work with some third party that's then got capital on the other chain to be able to kind of give you some virtual representation of the assets you parked on your original chain. And you have this really inexpensive, really inefficient system, which requires, capital to be deployed on both sides. It's, kind of then by definition extractive in the sense that somebody is like putting this money to work and obviously will need to will want to earn from the fact that they're doing so. And you also are crossing this trust boundary. So for example, if the contract on the first chain gets hacked, the value on the second chain that you bridge to is unbacked. So it's a weak point, it's extremely capital inefficient, and it requires trust, right? You require a third party. With zk, and when you're building systems designed in a certain way, which you can expand on, it was interesting, but essentially you can build this sort of messaging to be trustless at the protocol layer. So what this can mean is that, for example, people can deploy multiple hyperchains, so they can deploy rollups into this shared environment, which has certain common properties that means those rollups can interact permissionlessly. So a user could be have their account on hyperchain A, and they can interact with a contract on hyperchain B. Or they could send value to their friend, send 10 USDT to their friend for coffee on a totally other hyperchain, and it's done permissionlessly, extremely quickly, and most importantly, moves away from this like park capital model, because you can burn the value on chain A and then mint the value on chain B. And it can all be done without these trust assumptions because of zk. So because you can prove what you did on chain A, you can, chain B doesn't have to trust chain A. It knows that this thing happened. So you can just build systems that have these nice properties. So essentially the vision for the hyperchain ecosystem is that anybody can build out their own rollup. They can use the toolkit that we've developed called the zk stack, deploy these systems that remain fully sovereign. They're customizable so that they can build it, in a way that makes sense for their use case. But they start to inherit all of these nice properties, including things like being able to recurse all of the proofs, so the proofs get sort of combined down and verified on Ethereum. So no loss of verifiability, no loss of security. And you really start to be able to see this environment that can scale in a way that makes sense.
Very cool. I have my own layman version explanation of hyper-scalability and hyperchain. So just imagine you have one highway, millions of cars getting onto it. No matter how fast the cars go, it's still going to be eventually congested. Now imagine you have 10 highways. You have options to pick which highways you want to get onto, and you can interact across different highways, basically allowing you to know information, or even just switch your car from one highway A to highway C, highway D, very easily, very quickly, right? So that's hyper-scalability. I think that's really as simple as that, but it's going to be one of the most important concepts in layer 2 scaling to me. Now, I've done a bit of research before I came, and I realized that zkSync has facilitated over 230 million transactions since launch. 230 million transactions. That's a huge number. Now, Anthony, would you be able to tell us what insights have you gained from these volume activities from the point of view of user behavior, network demands?
Yeah, it's a fun one because we launched the system.
Sorry, we are losing you a bit.
Oh, can you hear me now?
Did you
lose the audio?
You're coming in. We hardly can hear you.
Can you hear me now? I'm not sure. I can ping the organizers.
Okay, but it's better now. Okay, cool. I think we got it.
Cool,
yeah,
cool.
That's good.
So I was saying, it's a fun one when you launch these systems because you don't necessarily know, it's a permissionless system. You don't know who's going to use it. You don't know how much usage you're going to get. So really appreciative of the level of activity we've seen, really validates a lot of what we've been doing. In terms of how much we learn, I would say it's mixed, in part because the users that are using crypto today probably aren't the users that are going to be using the system, 1 year, 5 years, or 10 years from now. And this is in part because, almost by definition, I would say like crypto native people today are in the like early explorer category. And we haven't yet got applications that have, crossed into the mainstream in a way that we really want to see, right? Like there aren't many crypto applications with, 1 million daily active users for working towards, Twitter scale, Facebook scale. Like how do we get there? So I think what we learned today is important. But we also have to remember that we're building for a very different user group as well. We need to make these, applications cleaner. We need to trend towards Web 2 usability. But the things we do learn, we learn a huge amount about the system. We had one fun event with inscriptions being launched on zkSync. And in one day, we processed something like 6 million transactions. So you learn a lot about where your system has bottlenecks. You learn a lot about where it's not as resilient as you want. So all of this activity has been really helpful in us refining the design of the system and, iteratively improving the way that it works. So, the volume has been amazing, but at the end of the day, it's still a drop in the ocean for what we're expecting to get to. So, continuing to push on the performance of the system, continuing to make it cheaper, and continuing to think about the user experience and how do we make it more Web 2-like is all like important as much as, you want to improve the system today.
Oh, very good insight. Just maybe switching lane, the other end of the spectrum. zkSync has more than 1 million contracts deployed on chain. How does zkSync handle I'm sure it's a very diverse requirement of builders and projects who are building on zkSync?
Huge number of contracts being deployed and interesting to see the variety. I would say one of the challenges we had early on was because we built our own virtual machine, many of the tools that developers were used to using didn't work, right? They kind of assumed that the system that they were working with would use the EVM bytecode. Our system doesn't, and optimize the bytecode to be more performant in zk. So when we were thinking about, developers, the developer experience, and really trying to build for them, it was, invest a lot to kind of bring back the functionality that was missing at the start when we first launched the system, honestly. So things like Foundry, things like Remix, things like Hardhat. So we've done a ton of work to get to the point where these tools are starting to get to the point of being as good or almost as good as they are on L1. And obviously going to spend a huge amount more time on this to get towards where we want to be, which is the tool chain is amazing, the developer experience is amazing. But then, it's important that we stay close to the builder community. So, we have DevRel team working closely with the engineers and teams building on zkSync to get the feedback very directly and really try to internalize the developer experience and make it better, and to be builders ourselves. So some of our team, part of their job is to build applications and build things on zkSync so that they understand the developer experience in a very real way and, can feel the pain of the developers and try to iterate and try to make it better. And because ultimately our first users are developers, right? They are building for their users and we want to make it a really good experience for them.
Very cool. Very, very cool. I'm sure many of us in this room are big zkSync fan like myself. Can you share with us what are the next big milestones for zkSync and how do you plan to continue to support the huge growth of Web3 ecosystem?
Yeah, the first thing I would say is I think we own the community a roadmap. So we're on it. We'll be saying a lot more and committing more to a more long-term view of what's coming. But to maybe share a few fun highlights that are on the near-term horizon. One of the biggest ones is actually the next protocol upgrade, which may be the most complex upgrade we've done since we launched zkSync. And this is actually the transition from the hyperchain ecosystem being zkSync era to actually it's starting to be much richer, and we'll start to see these other systems get deployed. So in the coming weeks, Era's bridge on L1 on Ethereum is being upgraded into the shared bridge. So this will be the bridge that effectively opens the door to the highway that you described. So it's the highway for these hyperchains to be deployed. This has been through all of the security reviews, and we're at the point of basically, deploying this to mainnet. So after this, we'll start to see other systems going live on mainnet, where these first hyperchains alongside Era will be deployed. And then you get to see some of the more exciting upgrades we've got, where we start to realize the value of this ecosystem, including things like interop. So enabling this hyper bridging between these systems, and also for these systems to also be able to combine their proofs. So rather than every one of these rollups having to do the work of verifying its own correctness on Ethereum, proving on Ethereum that its zk proof was correct, we'll be able to aggregate all of these proofs. So there's a single proof for the entire hyperchain, which means that the on-chain transaction costs can trend towards zero, because you're sharing, this expensive step on Ethereum among the whole hyperchain ecosystem, not just one rollup or, a small set of users. So lots of work on enabling the vision for the hyperchain ecosystem. Era itself continues to get better. We have upgrades to the virtual machine, continue to push performance, continue to improve the developer experience. And coming back all the way to maybe one of the first things we talked about, like decentralization is coming. So as I mentioned, we have a version of the sequencer, which is working in kind of private testnet. So we have a decentralized sequencer that we will be bringing to mainnet. And we're also thinking a lot about, what's the future of the network? How does it get to be this open protocol that is much bigger than just Matter Labs? Many teams contributing to its success, many teams involved in governance. All of this is coming. So yeah, this is an exciting year. And last year, is the year of launching, and this year will be the year of scaling and opening up the protocol.
Very exciting. Thanks for sharing that insight with us. You heard it, ladies and gentlemen. Upgraded bridge that will facilitate transfer of tokens between hyperbridge easily, hyperchain easily. There is a upgraded proving system that will be super efficient, lowering gas fee. That can only translate to very, very low gas fee, very, very fast transactions. I'm really excited for those upgrades coming on. I'm afraid that's all the time we have, Anthony. Thanks for waking up and calling in. Round of applause for Anthony Rose, City of zkSync.
Thank you for having me.
Thank you. Pleasure speaking to you, Anthony. Thank you.
Likewise. Bye, guys.